looking at solving exponential equations. So exponential equations are when we have several powers and normally the x that we're trying to solve for is part of the power. Now the way we solve for exponential equations is by something called equating bases. Essentially, if you write the equation or manipulate it so that both bases are the same, you can then equate the powers. You can say, well, if the a's of the base are the same, therefore 3x must equal 12. And we would write 3x equals 12. Clearly divide by 3. X is equal to 4. Alright. So, if we get the base the same, we can equate the powers. Similarly, and this is quite rare, but you might as well see it, equating the bases. Here, you can see the powers are the same. So if the powers are the same across an equal sign, therefore we can say, well, A must equal B. We can equate the bases. A slightly different example might be, say if you had 2x plus 4 to the power of 7 is equal to x plus 9 to the power of 7. You could therefore say, well, 2x plus 4 is equal to x plus 9. Alright? So, don't be tricked. Just because you've got it written in bases and powers, if they're different, you can't say x is 6, and if the powers are different, you can't say a equals b. So make sure that either the powers are the same, or much more commonly, the base is the same and you're equating powers. Alright, so how do you solve these? You solve this type of equation, by hunting for a common base. We want the bases to be the same so we can equate the powers. Now here, I'm going to leave 9 to the minus 3m, and I'm going to recall that 1 over 81 is really the same as 1 over 9 squared. 9 squared is 81, and that's really the same as 9 to the minus 2. So, instead of writing 1 over 81, I could write 9 to the minus 2. Therefore, because the base is the same, I can say we're going to equate the powers, and therefore minus 3m is equal to minus 2. Dividing both sides by minus 3, m will equal 2 on 3. The negatives cancel. Right? So we're aiming for the same base and then equating the powers here. And the trick is really about hunting the base. Now, sometimes we could have gone to 3 there and we'd have got the same answer. Generally, the bases will be 2, 3, 5, 7. And you'll be expected to know all the way up to really 2 to the power of 6, 3 to the power of 3 you should know. You should know 5 to the power of 3, and I'll give you a hint. 2 to the power of 1 is 2, 4, 8, 16, 32, 64, 128. All of those numbers there, if any of them appear in a question, you should be thinking, I'm going to use a base of 2. Same here with 3, 9, 27, 81, 273. Any of them appear, you should think base 3. 5, 25, 125, think base 5. Now, they're the ones that are most common, but it can be anything and the logic works with everything. Alright, here, since we have a 4, a 16, and a 64, they've all come from here, so let's try and get everything in base 2. Starting with the first expression. 1 over 4 is the same as 1 over 2 squared. 2 to the n. Now 1 over 2 squared is the same as 2 to the neg 2. Multiply. Note that little dot in there is just another symbol for multiply. Now, we know that 2 to the 1, 2, 3, 4, 2 to the 4 is the same as 16. And then 2 to the 6 is 64. Think up here, 1, 2, 3, 4, 5, 6. And it'll be worth having them down somewhere in your reference book. Alright, now, simplifying these out. When powers raised to another power, it multiplies. This becomes 2 to the minus 4n. This 4 is multiplied by both terms there. So this is 2 to the 8 minus 4n equals 2 to the 6. Now, when you've got the same bases here, you add the powers. So we're going to add the powers and write that as a single power, single exponent. 2 to the power of Minus 4n take 4n is minus 8n, so it'll be 8 minus 8n equals 2 to the 6. Now, no, same base, so we can equate the powers. Therefore, we can say 8 take 8n is equal to 6. Then it's a matter of solving that. Take 8 from both sides, minus 8n is equal to minus 2. I really should put these in here, shouldn't I? Take 8, take 8. Then we're going to divide by negative 8, divide by negative 8. Negative 2 divided by negative 8 is positive a quarter. N is equal to positive a quarter. Alright, so once again, do some algebraic manipulation. You need to get quick at this in order to get the base the same. Simplify to this stage, then equate powers. Alright, last one. Now, 36, 216, 36. Well, 36 we have seen before, not in this video, but you should know that 6 squared is equal to 36. Now, we're not sure about 216, but it turns out if you do 216, and you're sort of guessing that 6 might be involved here, so if you divide it by 6, that's 36, meaning 6 to the power of 3 is 216. So the base we're aiming for here is a base of 6. Quite unusual, but doable. So instead of 36, I'm going to write 6 squared, 2 take 2v, times 6 to the 3, 2 take 2v, don't know why I wrote 4, 2v, equals 1 on 36 is 1 on 6 squared. To make that as a single exponent, we would write that as 6 to the neg 2. Now, multiplying out the tops here. 6 to the 4 take 4v, multiplied by 6 to the 6 take 12, take 6v, equals 6 to the minus 2. Now, add the powers to get a single base. So, adding these two powers, there and there, 6 plus 4 is 10, so it's 6 to the 10, adding minus v is minus 10v, is equal to 6 to the minus 2. Then, we can equate bases. Equate powers. So we can say, well, therefore, 10 minus 10v is equal to minus 2. We can subtract 10 from both sides. Minus 10v is equal to minus 12. Divide both sides by minus 10. V is equal to, well, 12 on 10, or it's the same as 1 and 1/5. Alright, now, instead of doing something on Kahoot, this time I like to do something, instead of doing something on OneNote, practice questions on OneNote, what I would like you to do now is log into join.quizzes and enter that game code. Then enter a name that I know is you, so that I know you've done it, because this is your homework. Answer the 4 or 5 questions, and that is instead of OneNote. That's what we're going to do differently from now on. We'll try little quizzes, the links, instead of entering it all on OneNote, and then I'll be able to see who's done the quiz, who's done it well, etc. Alright, thank you very much. Enjoy the quizzes.